After completing this video, you will be able to describe the integration of large language models, LLMs, instructions, and tools in AI agents. Let's go back to the diagram we had previously drawn about how AI agents work. Remember that at the heart of the diagram, we had the components of the agent. We had put those down as LLM, instructions, and tools. And that indeed is what we are now going to talk about. We are going to focus first on the models that the LLMs, then on the instructions, and finally, on the tools available in the Azure AI Agent Service. Let's start first with the models, which we will cover rather quickly. LLMs and agents are really the brain. These need to be able to integrate with tools as well as data sources. And of course, as we've discussed on TWI, there is a wide range of models from different model providers available in the Azure AI Foundry. Remember again that these models, these are LLMs, have memory and planning capabilities. As far as their role in agents go, these capabilities are more important than their formidable language processing abilities. Now, of course, that's not to downplay the importance of language, because the agents need to understand and generate natural language, and the LLMs are responsible for this. In addition, they need to autonomously plan and execute steps. They need to break down complex problems into manageable subtasks. And finally, they need to retain control over the interactions. This is very important. And in order to do this effectively, they need to be able to retain context from previous interactions and also learn from past behavior and past mistakes and adapt their behavior accordingly. Let's very quickly list out the supported models in the agent service. And of course, Azure OpenAI, Meta, that's the Llama series, Mistral, Cohere, and models from AI21. These are the Jambo models. Next, let's move on to instructions. These have an important role to play in the Azure AI Foundry agent service. These are pivotal in defining the agent's behavior, objectives, and constraints. These instructions will guide the blast, the decision-making processes, and tool utilization. Some of the aspects of instructions in agents are similar to that of system prompts. For instance, defining agent goals and behavior, an instruction to act as a helpful HR assistant or respond in a formal tone suitable for corporate communications is very much like a system prompt in a chatbot. However, instructions also have to guide tool usage. They need to inform the agent about when and how to make use of integrated tools. So an instruction might state, use the Bing search tool for real-time information queries. This is clearly starting to go beyond the role of a system prompt in a chatbot. Then, agents can enforce constraints. For instance, they might set boundaries to ensure compliance and safety. If you would like a few laughs and you would like to understand how important constraints are, well, you can search for an article from the Washington Post in February 2025. The headline reads, I let ChatGPT's new agent manage my life. It spent $31 on a dozen eggs. Finally, we can customize the behavior of agents for very specific tasks. For instance, if you have a trading agent, you might give it instructions like, always buy at the Holy Sun and sell at the offer. Based on this, let's categorize instructions into some important types. There are behavioral instructions, task-oriented instructions, which focus on specific tasks, such as provide product recommendations based on user preferences alone. There are tool utilization instructions. Use the Bing search tool for real-time information queries, or refer to Azure AI search for internal docs. And finally, there are constraint-based instructions. Avoid paying more than $7 for a dozen eggs. Finally, let's turn to the most important of these three, and that is tools. Tools can be thought of as modular capabilities that extend an agent's functionality by accessing external data sources or performing specific actions. Tools extend the capabilities of the LLM component, for instance, by getting data from external sources or executing specific functions. Also, they can be dynamically invoked based on the interaction, so the agent will have to automatically and autonomously decide which tools to invoke during a conversation based on the user's query and the context. They obviously need to integrate with external systems, and this can be done via Azure Logic Apps, Azure Functions, as well as third-party APIs. Finally, they also can ground their data in data sources using Azure AI Search or Bing Search, so they have all of the benefits of RAGs along with these other capabilities. We can categorize tools into three types: knowledge tools, action tools, and third-party tools. Let's walk through examples of each of these three types, starting with knowledge tools. First on the list is our very own Azure AI Search. Then there is File Search. File Search allows agents to search through unstructured data in uploaded files, such as PDFs or Word documents. Then there's Microsoft Fabric. This integration of agents with Fabric is in preview, by the way, but it could be extremely powerful. Then there is grounding using Microsoft Bing Search. This can be used to fetch real-time information from the web. Then there are action tools. First up is Azure Logic Apps. This is a low-code, no-code solution which allows agents to initiate and manage workflows. It integrates with a function. Very large number of connectors, 400 odd across Microsoft, as well as third-party services. This allows for complex process automation without extensive coding. Next, there's the OpenAPI Spec tool. This allows agents to interact with external APIs as long as they have been defined by OpenAPI 3.0 specifications. So you can import an existing OpenAPI spec and then have your agent seamlessly integrate with it. Then there is good old-fashioned function calling. So here our agent can invoke custom stateless functions that we have defined. And this allows for very precise control over agent behavior. We can use this for data processing, performing calculations, or interfacing with other apps. Agents can also execute Azure functions. This is particularly useful for handling event-driven tasks, processing streaming data, or integrating with other Azure services. Finally, there is the code interpreter. This allows agents to write and execute Python code within a sandboxed environment. This is useful for dynamic computations, large-scale or small-scale, data analysis, and generating visualizations on the fly. Next, let's talk about a list of third-party tools that are available as of very early June 2025. There is Aquan. This has AI-powered workflow, automation for institutional finance. Celonis, which has process intelligence for enterprise AI at scale. Then Insure MO. This provides insurance quotations for car, home, and travel. LegalFly. This gives legal insights grounded in trusted sources from a jurisdiction that you can pick. LexisNexis. This is a provider of legal and public records databases. Then there's MeHCM. This is short for Micro-Image Human Capital Management, and it provides facilities for employee profile management, attendance tracking, payroll, HR analytics, and learning systems. Morningstar, which is well known for its investment research and data, including analyst findings and expert commentary. TradeNo, which offers latest studies and past shipment data for trademark sales. And finally, the well-known TripAdvisor Tito. Here they are, all in the form of one large table, going beyond the scope of the exam. You might want to look at the descriptions here and see if there are any possible use cases for this in your enterprise. Broadly speaking, there are all of the Azure and Microsoft-related tools, and then there are all of the third-party tools down below.